Yes. Is it okay, voice now? So, good afternoon, everyone. We are going to start today's session. And today we will be again restarting with the Cox proportional hazard method of estimation of survival data. So, could you guys practice with the data set which we have shared? Although a less number of people are here, but still, could you do something at home? Okay, so if not, or even if you have done it, I'll revise it once and we'll see. So this I will import this. I'll go to the second day and here the data set is here. So this was the data set and we could do up till this point that we check the proportional hazard assumption and I will again explain seeing the data. So this was a data set and we have used this paper. And this paper, this was the reference article, which was like breastfeeding education, early skin to skin contact, and other strong determinants of exclusive breastfeeding in urban population, a prospective study. And they have done the modeling and seen the association using the Cox proportional hazard method. So this is your how to go for Cox proportional. So I'll go in this analysis in survival, and in survival there is this multivariable Cox regression and adjusted survival. This option I will click, and then such window will appear. So here on time elapsed, you have to shift the time to event data, that is the TT, which is a continuous variable. On the outcome, you have to shift the event, and event we have defined as termination of breastfeeding or not cessation of breastfeeding. That's the other. So here termination is your event, and then those who could not who did not meet with this event, because in survival analysis we define two concepts. One is the survival time and second is the event. So event is always known as failure, and the survival time is like proportion of people surviving past that particular time. So we have these are the variables. So what is the advantage of Cox proportional? Because we have seen that in Kaplan-Meier and in life table, you can only see one variable. Like you can compare the probability across only one variable. And like if there are many variable and if you want to propose something, then in that case, you cannot go with the Kaplan-Meier because that gives you unadjusted values. So this Cox proportional takes care of many variable at one time, and again it is semi-parametric in nature. So we have learned that day that because of its semi-parametric nature, it is very popular because it has got advantage over Kaplan-Meier because you can test many data. Even you can test the continuous variable, because Kaplan-Meier you can only do the comparison between a categorical variable, but here you can see the continuous variable also. But and how it is semi-parametric, because there are many parametric model also, like exponential, Weibull, increasing and non-decreasing, and those parametric model, again, if you apply this Cox regression, the values will be very much similar to the parametric one. So that's why it is so popular that even if the data is demanding a parametric model, people go for Cox proportional because the values and estimates which you get, it is very much similar to the your parametric one. Then we have learned regarding assumptions. So one of the assumption was like we have learned regarding the time dependent variable and time independent variable, and we have learned that there are variables like gender of the person which is time independent. Even if there is a passage of time, it will be fixed, but there are variables like blood pressure and many continuous variable which are changing over the time. So how to deal with that? So you just test, you assume that whatever variable you take, that is time independent. That means they are fixed. That means the hazard ratio across your categorical or continuous variable will be fixed, even if the hazard is changing, but the ratio will be fixed. And that is known as the proportional hazard. And how to test for this proportional hazard? So proportional hazard we test with the this option here in the graph, if you see, there's a plot option, this plot, not plot option. And this you check with the proportional hazard assumption, where you can see there's a Schrodinger residual, Schoenfeld residual. And Schoenfeld residual, you see the individual values of Schoenfeld residual. And you see that it changes. That day when we were applying the Schoenfeld residual and test of proportional hazard, it was giving something like E minus 1 and E minus 5. Now here in one table, you can see it is giving you the usual value. That means it is not like taking E as a power. So if you see, we say that the values which are more than zero point 0.5, we want non-significant p, 0.05, we want more than 0.05. If the p value is more than 0.05, we say that the proportional hazard assumption is met. In this case, gender of the baby and this marital status is definitely not, and this is the global. So I will again move this marital status back. So there were only 4 variables which were fulfilling this proportional hazard assumption. So I will move this variable back. And here I think there was one breastfeeding. I wrote on my diary that day which were the variables. So there were 4 variables, breastfeeding within 1 hour. So this was again one explanatory variable where the proportional, if you see the value of P, breastfeeding within 1 hour. So breastfeeding within 1 hour. And this was the within 1 hour, again, it is 0.7. If you see the values, now all values are more than 0.05. So if it is more than 0.05, you can say that the proportional hazard assumption has been met. And these are these we check with the Schoenfeld individual test for the checking proportional hazard assumptions. There are other methods also, like there's a log minus log curve, which we test in SPSS, but that option is not there in GEMOV. And again, you can enter these variable as an interaction variable with a time dependent covariate and see its p-value. That also you can do, but we have not told you that because this is a simpler one to test. And if this shows that p-value is not significant, that means what does it show? What is the interpretation? That with passage of time, these variables are not changing. That means your this proportional hazard assumption that's met. So that's why you don't you use this option. And then these were the way, if you see, this is your table where it gives you the univariable and multivariable hazard ratio. We know how to interpret hazard ratio. So if you see, I have made this model with 4 predictor. There are 4 predictor: gender of the baby, education of the mother, breastfeeding within 1 hour, and the breastfeeding education, which is a continuous variable. Number of education, prenatal education session received by the mother is this variable. So if you see the p-value, this is not significant. This is not significant gender, but this is significant mother education, the breastfeeding within 1 hour, and the this breastfeeding education. So this is your categorical variable. So this higher is the reference. So it tells you like the lower education is protective. That means the hazard is, if you want to express in terms of percentage, so you can say hazard is 33% less in the mother who are having lower education. Similarly, the hazard is less in mother who have initiated the breastfeeding within 1 hour because it is 0.5, 50%, 49% less. And here you can say with every one session increase in, because breastfeeding education is a continuous variable. So for continuous variable, how do we express? Like when 1 hour of session is increased, then there is a increase. This 1.16 means 16%. You can see that there is a 16% increase hazard of cessation of the breastfeeding. Now you see in this case, here you can see model metrics, it gives you like this. So these are the model metrics. It tells you like how many data it has, how many number of people in the this model, and what is the event. So there are 169 events and rest are censored. And then you can see it gives you something like a concordance. So now I will explain what is this concordance, because we could not discuss this that day, the model matrix. Although, like in logistic and regression, you have seen that it gives you 3, 4 model. But here in this case, we don't have much option. Why? Because here you can only enter those variables which meets this proportional hazard. So my number of variables got fixed. If you wish to change it, like maybe delete some, uh, take less number of variable, then you need to duplicate this result, and then you can check like in model 1, 2, and 3 which one is better. So if you see this, if I write here in this case, this is, suppose this is my model number 1, where my concordance, if you see the values of my model estimator, there is something known as the concordance, there is something known as the R square, and there is something known as the likelihood ratio. So these are the 3 terms. So now I'll explain this concordance, R square, and likelihood. You must have heard regarding this R square in the regression. Those of you who have attended, even if not attended, you know this, what is R square. So how do we explain R square? That is the if it is like 0.125, that means we multiplied by 100, and we say that 12.5% of the variation in the dependent variable, which is my event, like event happened or not happened, and when it happened, it is due to expressed by this model. And then concordance, it is very much similar to AUC. AUC, if you I will take the session of ROC, there we will understand what is this AUC. AUC is the area under the curve. So generally we know that it is the discriminatory power of your cutoff or your model. So if AUC, what is the minimum like acceptable value of AUC in case of ROC? So it's generally 0.7. We say that 0.7 should be we will learn this, but just to make you understand regarding concordance, what is concordance? So this concordance is very much similar to AUC. Remember, in logistic regression also we calculate AUC of your cutoff, 0.5 cutoff. Yes, I think Priyanka and many of you have attended that workshop of logistic and regression. So this cutoff is like you decide, we take this arbitrary cutoff, and then you see that this basically this concordance, this gives you the value of, it is like AUC, and this concordance, like it tells you in a pair where you can say which person will meet the event first and which person will not have the event. So this concordance, how do we interpret this concordance? So this concordance, like if you see, this is the value of C index, which we generally remember that if it is if it is zero point 0.5, if it is zero point 0.5, then like AUC, we say that it has got no discrimination bar. If it is zero point 0.6 and 2.7, we say that there is a moderate discrimination. And if it is like more than like acceptable is like, even if it is between 0.6 to 0.7, you can say moderate discrimination. But good is like when it is 0.7 or more than 0.7. This is regarding your C index or concordance index. We also call it as a concordance index. And in case of a R square, generally what is the acceptable? So even if it says that most of the survival model, it has got like 0.05 to 0.15. In our case, it is 0.125. So that is acceptable. Why it is acceptable? Because it is very common for survival models, because there is a lot of censored data. So because of that censored data, even if it is such a low R square, it is acceptable. That's regarding the R square. And then again, likelihood ratios test. What is likelihood ratio? So likelihood ratio, we say that if you take the model without any predictor, that we call it as a null model. And if you make the model with the all predictor, then what is the increase? If does these predictors significantly improving the model fit? So that's your likelihood. So the larger value of likelihood, better your model is. And in this case, if you see, it is the 26 point, I think 14 or something like that. It is, if you see the likelihood ratio, it is 26.619. So it adds, and this p value is also significant. And this degree of freedom is the number of predictor. So if the number of predictor is 4, the degree of freedom will be 4. So it says that yes, this model is it's better than null model because it is significant and it is adding to your likelihood ratio, like its value is positive. So that's how we interpret the model matrix. Model matrix means like you say that whatever with what variable you have formed this model, or you have shown the association, that is regarding your this making of these model with these four predictors. Now coming to other options, we have discussed this. Now coming to risk groups, there's an option which is known as the risk group scoring. Can you see this risk group scoring? So this risk group scoring is also good. And what is this risk group scoring? So I'll first explain what is this risk group, and then we'll see how those variable gets added into the data. So this risk score, basically, what is this risk score? With the value, remember the Cox proportional hazard equation. What it does, there is a ht, which is hazard function at time t, is equal to h0 multiplied by exponent of all these coefficients like beta 1 x1, beta 2 x2, and so on. So this risk scores, what it does, so that was a function of exponent, but taking it as a linear function, like remember the linear regression. So it calculates with all this beta 1 x1, beta 2 x2, taking the beta 1 coefficient and the value of that particular predictor variable, it calculates a risk score. And this risk score, based on this risk score, a ranking is done of all the individuals. So it calculates a risk score for all the individual, and then you can define like which cutoff are working well. For example, and then based on that risk score, it gives you again one index. There was one concordance index, which we have seen, and there is a Harrell C index also. So this Harrell C index is again like AUC. These are the ways of telling the discriminatory power of your model. So it again says that if it is 0.5, then there is a no discrimination, and acceptable is 0.7, or even if it is 0.6 to 0.7, you say that it is moderate in nature. So this Harrell C index is again the same thing. So like concordance means I'm not going into the detail of how these values are calculated, because that will take too much of time and that is not needed for you people also. You just have to understand the output and the rationale behind that output. So Jamovi gives two output for this the discriminatory power of your model, which you have made with all these four predictor variable, and it gives you a Harrell C index and the concordance index or the C index. Values of both are like same. It is very much similar to the area under the curve of a ROC. And if you see here, if I go and click this calculate risk scores, and you plot group risk survival also. And then there is an option of add risk score to data and add risk group to data. So if I go here, if I come down, I am unchecking this proportional hazard because it will just increase the number of output. So I'm just like not having this for now. So this is your risk score analysis. Again, it is giving you here also some theory part, how this risk score was calculated. So this risk scores were calculated using the coefficient from Cox proportional hazard model. And these risk score represent the predicted risk of event occurring based on the combined effect of all variable. So if I have decided, it asks like how many number of risk group you want to make. So I have like made on basis of the quartile. So I've just clicked 4 groups. So it is writing like it divides all the individual into the 4 group, depending on like less than 25th percentile, 25th to 50th percentile, 50th to 75th percentile, and above 25th percentile. And then it calculates the Harrell C index. So Harrell C index is again 0.63, which indicates its model discriminatory ability, whereas the 0.5 suggests no discriminatory ability, and 1 indicates perfect discrimination between risk group. So it calculates these 4 and it then calculates the median. So median for all these 4 quartile. So you see that median is going high. That means with the high risk, this if you are moving, there's a high risk, your survival is less. That means the event probability of having the event is high. And this is the graph. This graph, it gives you like there are four graph here. There's a low risk where the survival probability is the best, which it lies the topmost, followed by this orange one, which is the intermediate low risk. Then there is a blue, and then there's a pink, which is the high risk. And if you see the log rank of all these four comparison, it is less than 0.01, so it is significant. It just gives you the number at risk, and this graph gives you the number of censoring. So it is also a good representation, because if you see the time in months, I mean, it is time in days. You can like convert this from this option, which we have learned that day. Like click this, use survival time, and then change this from this was okay, this from months to days, and then just see. So now it will appear. Okay, this is not appearing in days. This is still, but again, this is in month. And this you can see like censoring is across all the intervals. So remember one assumption we have learned on day 2, that was the informative and non-informative censoring, and this and the pattern of censoring. So this overall random distribution of censor data tells you that it was random and it was not a typical, any pattern you cannot detect. So that is a good thing, and you can say that that assumption is also met seeing this number of censoring. So this is regarding the risk score or the risk score analysis. And if you see the data, if I come to the data, remember in logistic also and in linear, it adds a data column to your existing data to show the so if I go to the data, why it is not showing here? The data is not appearing. Let me do it again. Check it. 4 groups. I'll go to the data. The 2 columns that appear here, I don't know why it is not happening. I may again close this. Okay, let me see. No, it is there. It will come. Let me wait for some time. At times, let me close this. Don't save. Sometimes what happens, like Jamovi, the same command which you have got few minutes back, it failed to give you if you perform like after some time. I mean, reason is not known exactly. Let me see this data. No, here there's no column. So you can go to this risk and then calculate risk, plot risk group survival, and add risk score to the data, add risk group to the data. So now it gives you these risk group survival plot. This tells you the lower risk and all, which we were just seeing. This gives you the graph, and if you go to the data, now it is giving you, see, this overall calculated score, and this score is calculated using this formula, this one. The risk score is like beta 1 x1, beta 2 x2, and beta k xk. So using this, it calculates this this score, and based on that, it divides it into 4 group, 1, 2, 3, 4 in the quartile. So we have divided this into 4 quartile, and then it is comparing the risk using these 4 quartile. Okay, so this was regarding the risk. Again, coming to the there's a very important and there is a good option of nomogram. So we have done this person time analysis. That day we did this person time analysis. We know what is this person time. And we have seen the adjusted survival also analysis. I just want to show this nomogram. Although this function, it is still, they are writing the module of it. So if I click this nomogram, based on this model, it gives you a nomogram. That means the individual score. So if you put the individual score of the patient here, it will tell you what is the risk of event or what is the probability of survival. So it is a ready to use, you can say, ready to use chart or nomogram. And see, it gives you like that nomogram scoring diagram guide, and the points per unit of linear predictor is 170. Linear predictor is this thing, and then they say like this much point they have given. If the baby is male, you will give 20 score. If the baby is female, you will give 0 score. If the mother education is high, you will give 58 number. If it is low, you will give 0. Similarly, if marital status is single, you will give 31. Otherwise, you will give 0. And similarly, for breastfeeding education, you will give, if it is 1 hour of session, you will give 0, 2, 25, and like that. And then how will you convert? So it is saying that total point is like predicted 12 months risk. But again, it is not complete. Why? Because there should have been one pictorial this thing here, but that is missing in from this Jamovi output. So we wrote to the Jamovi community, and I will again show you today this about this Jamovi community. Like if you have some issue regarding Jamovi, whether some particular option is not working, or since in this case this module, this nomogram is not showing up. So I'll show you, we wrote to Jamovi. So Jamovi, this if I'll show you this Jamovi. So go to this Jamovi desktop where you download the Jamovi, and here there is an option of forum. So if you click on this forum, then you can see there are two things. One is a general discussion and one is help. So in help, you can paste your query, and there are people who will reply. Maybe the Jonathan, who is the main like owner and maker of this Jamovi, or many other people are also who are writing the codes and adding module. So we have like put this request to them. So this request we put because we wrote like there we need help with the incomplete nomogram output in survival module, and we have given the snip here that this the same snip which I am showing you, that this nomogram is missing. And we have written like this makes difficult to interpret or use nomogram effectively, as I am unable to match total points of predicted survival probability visually. So I was just asking this, how to like get help in this. Then I think one person has written like, yeah, hi, thanks for reporting. I'll check the function to see what is the problem. There will be an update in Jamovi 2.7. That means they are still writing the module. This version which we are using, that is Jamovi 2.6. If I see this, let me see. This is your version 2.6.26, right? This is version 2.6. So like this person is saying probably he has added that module. So he has replied that there will be an update in Jamovi 2.7, and the survival module is being updated for that version. Okay, so still that work is going on. But again, he said that there is an option of side load. So he said that this is the one file. You can side load this file and try that nomogram to run. We tried that also, and that's why we have wrote that I downloaded the J survival, but the module icon not appearing in analysis bar, because there's an option here of the side load. Remember, I'll show you. We tried to side load it, but again, in all these options, we were not able to see it. So we have just put our query, and let's see, generally they reply within 24 hours. Generally they reply, even if it is taking long. I mean, it's a good option, and it's a good forum where you can go and discuss. And in case of this also, if you see, if you come to this general also, general, and if you like search, type something, then again you can get something like it's like what we say. There are many platforms now like Reddit, Quora, where if you ask some questions, there are people who will reply. So similar, this is a Jamovi community, and you can search also. If somebody has already posed that question, you can search that topic and see what the other person has asked and whether that question is similar to you. If it is different from you, you can again post your own question. You can share the screenshot and somebody will help you out. So this we have found out very good option, especially whenever we are like organizing a workshop, and these Jamovi modules, it keeps on adding every day. This time when we are doing this workshop, now the ROC has been changed completely and they have again added new module. Previously we done with the PPDA. Those of you who have attended, I think Priyanka have attended previously also, but now they have changed the module. So in new module also, if something you are not very clear, you can go back to this community, either in the general platform or in the help section. You can post your question and you'll get a reply. So this I wanted to like demonstrate. So this we have posted this question, but probably they are saying that this nomogram, which is a very good option, because in clinical setting we have seen that many times students come to us like they are doing some model making thing and they want to predict something based on lymphocyte neutrophil count ratio and many other parameters, the biological parameters, but you cannot with the equation. It is not a very ready to use tool. So nomogram is a ready to use tool. You just give score individual, and then in that picture we'll see in the Fagans, like there's a Fagans nomogram, we'll see just like in the ROC. So a nomogram helps you to take that clinical decision very easily, and like it takes less time also. So I am sure like in version 2.7, and they are saying that it will be updated soon. So this option of nomogram, which you can see here as an incomplete version, these are also like very lightly appeared, means, but again you can see some variable which they have shown, and based on that you will be able to tell the risk means hazard of in an individual person. If the person comes to you, if the lady, in this case, if the lady comes to you and if you put the age of the baby and the education of the lady, the marital status and the breastfeeding, if that is a variable, then you will be able to predict that, the exclusive breastfeeding will be only for these many days. Okay. Am I making sense to all of you? Okay. So Priyanka is saying likelihood ratio is same as a constant of regression equation. Okay. Is
Ma'am,
it?
I was asking that in the regression equation, we were having two constant, A plus B something. So A was that constant we were using as coefficient when all the predictor variable we were thinking to be zero, matlab influence of that.
Okay. Yes.
Is it equal to this likelihood ratio?
No, likelihood ratio is the another statistics which we calculate on basis on the chi-square test. So likelihood ratio is it's a chi-square distribution. We calculate it on the basis of chi-square, that predicted and observed survival probability. It is something like that. It is not related to that where
How
you
to
have defined that intercept. Here in case of intercept, you have got baseline hazard, which is H0T. Remember, in case of a survival, uh, this thing is H0T. It is not the any intercept is not there. It's the baseline. That's why that HT by H0 you call it as a hazard ratio. Okay.
Yes, ma'am.
Okay. So if you have understood this nomogram, so these two options are like newly added. This nomogram was not there previously, and this risk score was also not there previously. So these two options you can see here, it got added. So if you are okay up till this point, now we can go to ROC. So all these plot you can plot. You can like do this hazard plotting. You can show the adjusted hazard. So it's a like with these all modules and learning this thing. Now I think survival analysis is a very, especially those of you who are like working in clinical setting and even not working in clinical setting, you can like collaborate with clinical people, and you can like at least in ICU setting, with many variable you can predict like the survival, because there the study will be for a longer. You don't have to follow for very long time, because it will be like 30-40 days, maximum 2 months, the people who are there in the ICU. So I think that will be a good study. So I think I'm closing this multivariable survival we have discussed completely. We have shown you this Jamovi one, and now coming to ROC.